Good afternoon, everybody, and welcome to the Bold Inventor Show. You've made it. I'm myself, JD Hoovener, with Matt Colseth to my left.
Hello, hello.
Hey, guys. Matt, how are you doing today?
Little sick, little under the weather.
Yeah, man, I'm clearing my throat quite a bit here. I'm sorry to hear you're not feeling good.
Yeah, sorry to hear you're not doing well. Yeah, it's not terrible. It's just it's been hanging around for the last week or so. You just cannot get rid of it. So,
man. Okay.
Other than that, man, life's good. Let's do it.
Excellent. My kind of cold symptoms are probably due to my big party we did last weekend. We went up to Whistler, BC.
Nice.
My much younger brother is getting married here in May, and he brought a bunch of his wild buddies.
Cool.
And we guys are full of energy. A lot of good time up there.
Nice. Do you ski at all?
No.
Who goes to Whistler and doesn't ski?
I know. I whistled a bunch. I went up there. I checked out the snow, and I was like, you know what? This village is pretty cool. I'm gonna go walk around. I know. You're laughing at me.
That's great.
Yeah. Anyway. Well, we have got, for those that are tuning in here, I know you guys our live audience is just rushing in. We're live across Facebook, LinkedIn, and YouTube. We're attorneys, and we're talking about patents and trademarks, intellectual property as well. So other areas, including copyrights, trade secrets, a little privacy law. But I'm excited for our guest waiting patiently backstage, Adam Zimmer. As you saw from the headline, we talk about 3D printing, additive manufacturing. So I'm excited to bring him on, talk about what in the world has been going on with that, and how you might benefit. So this show is really for you, the inventor, entrepreneur, business owner, mover and shaker, world enter out there. So feel free, if you made time to show up live, I'm going to prioritize any of your questions. We've got 6 questions we had over the week come in, Matt. So crack your knuckles, straighten up, clear your throat. There you go. Yeah, that was audible. We got to get through these questions, and then we're going to bring our guest on.
Sounds great. Let's do this.
Little Shark Tank critique. So let's blast through. I'm going to put you to the test first. We've got a short question. Sometimes those are the most dangerous. Vertically
challenged questions are the best.
Yeah. This is I think on a lot of business owners' mind, maybe when they get started. So hypothetically, and I love it, that's what we want to do here. I create a business and I call my business name my last name. Can I technically trademark it? Like no. Disney, Hershey? What?
No, you can't.
You didn't stutter there at all, man. Okay.
Well, here's what I'll say about it. So one of the bars to trademark registration with the United States Patent Trademark Office is the surname refusal. So generally speaking, the rule is that we are not allowed to register our last names as trademarks because it would be unfair to all the other Hooveners and Colseths of the world if we had the exclusive rights to use that for any given type of service. Okay. That said, you can get around the surname refusal if you've become distinctive in the marketplace, despite the fact that your last name is a surname, right? So if you've been around for more than 5 years and you've garnered a reasonable amount of attention, then you could potentially claim acquired distinctiveness or secondary meaning and get around it. But generally speaking, the answer is no. We can't register a surname.
Got it. Not really recommended in your humble opinion. Got it. Cool. Well, that's a nice, simple, straightforward answer.
Real easy.
Thank you for that one. Let's jump on to the next. Let's head over to the patent side of things. I'll start with a warm-up, kind of an easier, lighter question. And this one is from our Reddit pool that came in. So what are the main challenges Asian companies face when enforcing patents internationally? This was interesting when I first read it, and now I'm reading it out loud. Okay, Asian companies. Let's see. I'm not sure, what that means. I mean, Asian-owned companies that exist in Asia. Maybe that's what that's a huge part of the world. Let's just say China. Let's just say a company that is a Chinese company. What challenges do they face when enforcing patents internationally? So if you are a Chinese company and you're selling, let's say in the US, what's a challenge that you might have? that differentiate. I don't know. I really can't think right now on my feet in terms of what additional or what barriers they would have as opposed to anyone else trying to sell in that direction. You know, you're gonna likely have to have, just so you all know, there are different patent laws on the books at each country. And so whether you're seeking patent rights or enforcing patent rights, you'll need to work with local counsel. Each country will have their own patent bar. And here in the US, that's what Bold Patents is. We help represent inventors that want to get or enforce patents in the US. So you'll need to hire a firm in the US to go enforce. Quickly, not answering too much here, I don't want to go too much longer on this, but if you're, let's say, a US company and you're selling in Asia, kind of the reverse of this question, you're now kind of, maybe at the burden, maybe this gets to the answer. And the question is, you're dealing with a different system. You now have to go learn about the enforcement mechanisms in those countries. And some are going to be more strict, some will be more lenient. It really is up to how they want to run their system and govern it. And so I would assume penalty, damages, right? How you can pursue licensing agreements, how enforcement's going to happen, whether a restraining order is really going to work, how customs work in those different countries. A whole host of different things come to mind. Matt, would you add anything on top of that?
No, not in particular, Judy. I think you covered it. After we wrap this question up, I did want to jump in and talk about some Chinese trademark registrations that are being vacated by the USPTO.
Let's jump right to that. Excellent segue.
Okay, yeah. So I saw this hit my newsfeed the other day, but the USPTO 3 days ago, let's see here, issued a show cause order to cancel more than 40,000 Chinese trademark registrations. So we've been 40,000.
40,000.
Yeah, it's a lot of trademarks. So for those who've been following along at home, the USPTO is way behind in terms of their trademark issuance and registration timelines. Part of the reason for that is the amount of Chinese trademarks here in the United States. The Chinese government for a long time was dumping or paying their companies to file trademarks in the United States. Apparently, a lot of those trademarks ran through this one Chinese company, or don't quote me on this, but one company called Cellular Growth Network Technology. And apparently, allegedly, they were basically filing trademarks for Chinese companies here in the United States using American attorneys' names, but those attorneys really weren't operating as attorney of record for the trademarks. Wow. So what's been happening recently for the listeners is we've seen a lot of paralegal firms outside the United States trying to get into the United States by having attorneys here in the United States co-sign their applications as a way of getting around the new rules that the United States, in order to have a trademark application here, you have to be represented by U.S. counsel if you're a foreign entity.
A U.S. attorney. You have to have a U.S. attorney somewhere.
Yep. If you're a foreign national or a foreign entity.
Yep. Okay. Wow.
We've seen a lot of attorneys get in trouble recently with filing these Chinese trademarks without really even looking them over, right? They're just co-signing these applications. Seen some attorneys, I think suspended from practice in front of the USPTO or potentially disbarred.
Yeah. Well, I guess that's generally good news, I think.
I think it's great news. About time.
I don't see any downside to that. Thank goodness. They'll send me a link to that. We'll blast it on our newsletter too.
Yeah.
That's wonderful. Okay, let's we'll do at least one more each here. I'll make sure we get some action. I did actually a little research on this question. I thought it was really, really good. We've got a doctor. So this person went to school for a very long time, got a PhD. So I developed a new technique to solve a specific problem in an electronic system. During my PhD studies at a U.S. university, vague enough, the work was presented at an I'm sure the word is refereed conference and became available and accessible in their proceedings. This person did not file anything at the time, but 1 year later, a very big corporate filed a patent with the exact same technique he invented.
You're going to get in the weeds here, aren't you? On the other time,
I'm going to dive in just a bit. So, yeah, it's like, go get him, David. And it's just like, heck yeah. And I assume being a PhD, you've got some documentation. You can provide some sort of affidavit, some concrete evidence of this transfer of knowledge. And so there's a couple different ways to go. There is the good old federal court system. There's also mediation arbitration to change inventorship. And that could be an approach. You work with a patent litigator and you threaten a whole other thing about you defrauded the patent office. You derived this invention from my client. If you don't change it, we will go after the attorney, go after the inventor for defrauding. It seems like what happened, if this is true, when you file a patent application, you have to sign and swear an oath saying that you are the inventor. Seems kind of basic. And if that was done with knowledge that they did not, in fact, invent, that is pure fraud on the patent office. So that is a great, I think, ammunition to get a nice settlement and to get things done from traditional litigation. There is a new avenue, relatively new, within the past 10 years. The PTAB created a derivation proceeding, which is pretty cool. It does come with a 1-year timeline. So you have to be able to catch them 1 year or less from when they filed it. So it's pretty tricky timeline-wise, but you can file this proceeding. The other catch is you have to file an application and say, yeah, okay, I got rejected by these guys, but they stole it from me. And that's how this petition works. So there's definitely a couple different avenues to go down here. And if you'd like to, we'd be honored to help you work through that. So pretty cool. There is justice, even against those very big corporate folks out there. Let's go back to the trademark side.
Hey, JD, quick question for you. When it comes to patent litigation, do most patent litigators take work on contingent fee? Or I guess it really depends, I would think, right? Maybe they do a kind of a hybrid where they do an initial payment for the initial lawsuit and then a contingent after that.
Yeah, well, we work with one in particular that does offer contingent representation, but there is this sort of initial chunk of analysis that is required. It's called a claim charting, where you really dive into each element of your claim and look at the accused product or the accused infringer and say, is there analysis to say, yes, each element of the claim is met. And if it looks thumbs up, there's a couple different routes to go on the contingency side, where you go after litigation financing, or if you just proceed with a bit more of a risky approach and the attorneys want to take it on. So yeah, good case. They'll be lined up to help you. All right, let's take one more on the trademark side. There actually were quite a few patent ones. Okay, another simple one, but I think it's good. I think it's one that comes up a lot. I don't think we've answered here, at least in a while. Is it possible to trademark a political slogan or a jingle? If so, what's the process for doing that?
Yeah, you certainly could if it's yours, right? If it's somebody else's slogan or jingle, of course not. You can't. But yeah. Yeah, I mean, all things sold, bought, proffered fall into one of those 45 categories at the USPTO. So I'd have to think about what this would be. Maybe an education class, because you're doing some advertising, promotion, education potentially. I don't know. That's interesting. I've never worked with a political group on a political application like this. So
how about the other side? And let's take an extreme example. Yeah. Kind of go, musical only, a tonal mark. 7 tones in a row.
Untraditional trademark.
Yeah, is that feasible? Can you actually apply?
Yeah, you can. So there are things called sound marks. They are extremely rare, but I'm thinking like back to law school, right? I think the example was like the NBC tones, do do do, or whatever it is, like something like that.
Was good.
Way off. But those have become distinctive enough that they're registrable as trademarks. But the bar to registration for sound marks, smell marks, olfactory marks, it's extremely high. So you're talking. You're going to have to bring in expert testimony. You're going to have to conduct some surveys. You have to bring an expert to discuss the survey to prove that your mark is distinctive.
Oh, that's great. Got it.
Yeah.
Got it. Not going to be,
cool. But yeah, you can.
Word marks.
But I would say, you're probably looking at least 20 grand. I would think between experts and all the research and surveys that are required. to even consider registering one of these.
Cool. Yeah. Probably one of those ones where you've been in business and done very, very well, and you want to just continue protecting your brand. And this is something not the first thing you're going to do.
No, this is moonshot for sure type of trademark application.
Got it. All right, Matt. Well, let's bring on our guest. He's been hanging out. Adam, welcome to the show, the Bold Inventor Show.
Hello. Hi, Matt.
Yeah, all right. I'm excited to have you on and, talk about 3D printing and a whole lot else and hear more about what D3PC, if I got that right, what you guys do. So maybe kick it off with that. Give us a little about your background personally, and then walk us through how you got started at D3PC.
Sure. My background is engineering. I went to Rose-Hulman in Indiana. And then I went to the military and then went into the private sector and was doing design engineering for an aerospace company. And that's where I first started to use 3D printing functionally. I was using early systems in like 2012, and we were making a lot of like test fixtures and jigs and things to make our assembly processes better. And then I moved on to the patent office, and I did a year there where I really found a love for intellectual property. And then it's wonderful. And then I moved on from that to be the CTO for a startup. And while I was there, I needed to make objects, a dispenser system. And so I bought some 3D printers with my own savings with the intent of, doing side hustle stuff. And that kind of just took off. And I started doing 3D prints for people, just normal, the standard hot glue gun style FDM prints. And then the next thing you know, people wanted different stuff. So they started to want silicone parts. So now I'm casting silicones. And they wanted very smooth parts, which you can't really achieve with a standard 3D printer. So I moved into SLA printing. And then they wanted a bunch of parts. So I start doing silicone molding with multiple cavities and casting that. And it just kind of has snowballed from there. So we pick up new technologies when a new customer comes along and wants to basically fund us getting something new, whether it's 3D scanning or any injection molding or whatever. So we'll kind of tweak our tech stack from a physical making standpoint based on the projects that come in. And we've been doing it for like 9 years now. So we've kind of, ramped up and got some machines, found out we don't really use them. And so we're kind of at a nice steady state when it comes to how we do our thing. So that's kind of how we got here. And so Denver 3D Print Company, we do a lot of different stuff. It's all surrounding designing and making of objects. And so we've got like 4 types of customers. The first would be people with products that they want to take to market. And so we have a whole kind of patentable product design process that we use with them to take their napkin sketch, turn it into something, prototype, iterate, and make it better and better until it's a final manufacturable product. And so that's one sect. Another is just problem solving clients. So those would be like artists that want to replicate their sculpture at a smaller scale so that they can essentially do, prints of their 3D sculpture.
Wow, that's great.
Yeah,
That's
it's
really
cool. Yeah, it's they have prints with 2D, might as well do prints with 3D. So and then we do ornamental architecture, so custom stairways, and we work at very large scales. So we'll 3D scan entire stairwells so we can design the perfect curve fit to match up, and then it's getting coated in leather. So there's a lot of like mixed modal kind of stuff that happens when you're just solving a problem. Or you want to mount some TVs to your office and they're, old style and you can't get a mounting bracket for it. So we'll design using CAD software, computer aided drafting software to design those things. And, we fold in a lot of different processes like 3D scanning when it comes to designing things. So if you have an old truck and you want the perfect fit for a little compartment that has a USB plug in it, we'll scan that area, we'll skin it out, we'll shell it, put in little, stiffening ribs and things, print it out, and then it'll be a perfect match fit. So we solve a lot of just random problems for people. And then the other clients are more for manufacturing. So we have low rate manufacturing people that need 500 or something. And for that, we'll use traditional rapid prototyping techniques. So 3D printing, there's a lot of, like you can get bent sheet metal rapidly produced now. And so we don't have all the machines, but we have connections to all the machines. And so when somebody needs something, we design it up and then we find the right source to make it, to get the right material and the right feel and everything. And then the last type of customer are mass production clients. And so those are people that want thousands of things because they're going to the market. And so we've got a sister company in Shanghai that we send all of our mass production stuff to. They kind of do it all. And if they don't do something, then they source the other parts. And since it's a Chinese company working with a Chinese company, you usually get better rates. And, they're just more timely in responses because they're working on the same time zone. And so that kind of covers what we do.
Yeah, that's great. Wow. Thank you for that. I mean, that really helps. I think, certainly your firm and our firm can work together on category one. I'd look forward to having some more discussions about how you work with inventors, and
Certainly.
maybe we can start with that, that type of client.
Sure.
Yeah.
Go ahead. I'm sorry.
Just saying, we've got a lot of individual clients and, individual, inventors, right? They're kind of doing it for the first time. They're pretty green. Mm-hmm. How do you work with someone like that? What's the first couple steps that you take with them?
Well, those are our favorite types of clients, the ones that come in with a napkin sketch and kind of a dream.
Yep.
Those people are really good inventors because the people that have the best inventions are the people that are doing the work. So when the plumber comes in and says, hey, I have a new way to carry a water tank around, you know that it's probably pretty good because he knows all the catalogs to search to find that tool, and he's actually looking for it, and he needs it every day. And so they'll come in and they, to start with a napkin sketch. Some are more advanced, some have made their own prototypes, which is very helpful because as an inventor, if you come in with a prototype and our job is to basically, clean up the prototype, clean up the design, make it manufacturable, add in patentable elements as much as possible, and set you up for success down the road. But if you come in with the prototype, I can take measurements on it. I can get the feel of it. We can get angles. We can scan it to give us something to work around in the CAD software, which basically accelerates the speed at which we can work, which saves you money in the end because we charge hourly for what we do. Just to talk through kind of how someone would work with us, they come in with a napkin sketch, say for a new golf club handle, which I haven't worked on before, but they have this idea. Well, if you got one, come to us, we can help you refine it. But they'll come in with a sketch and they'll say, this is basically what I want. Here's the problem I'm trying to solve. And then we sit down with the inventor and actually design it real time while they're sitting there. And that solves a huge problem because a lot of these design firms, the design gets thrown over the fence to them and then they start working on it and then it gets thrown back and they've gone in the wrong direction. And at the end of the day, a lot of hours get spent and you don't always get the product that you want. So sitting side by side with the inventor allows me to talk to them about it and say, okay, so you want to hold it like this? What about holding it like that? And so, me as like one skilled in the art of looking for patentable subject matter, I kind of know, the bars, is this teaching somebody something new? And so I'll kind of talk to them about the invention and kind of let their creativity open up, because they might not have seen that since I'm a fresh eyes on the thing and I'm just kind of a generalist and I do a lot of working on things and I have a lot of hobbies. I usually am able to ferret out kind of new little elements that we can add to this invention that basically adds structure, adds function, and adds patentability to your invention. So, and that's kind of how we work. You come in and we design on it. At the end of that design process, the goal is always to have something that we can make. And then we will prototype it. And we might prototype it in-house with different types of 3D printing, or we might outsource it. So if you wanted metal printing, that's something that we would send out. And then the prototype comes in, we hand it over to the customer or the inventor, and then they go out and test it. And then if they decide they want to further improve it, they'll bring it back to us and we'll do another round. So we just do iteration by iteration, and that's how you pay us. So round one, you pay us, you want to come back, pay us again. And that kind of puts the ball in the inventor's court to say this product is perfect or good enough. because there's trade-offs when it comes to a product. It's kind of a Venn diagram. You really need to consider manufacturability kind of at the core. And that's, I think, what makes Denver 3D Print Company special is we kind of do everything. We're doing manufacturing, we're doing design, and we're doing patents.
Yeah.
When it comes to patents, I'm not a registered agent or anything. We produce technical documents at the end of the process that they can take to an attorney, unless it's a co-invention, and then I will do the patent.
That's
anyway,
cool. Adam.
yeah. Go ahead. I'm sorry.
We got a live question here. We got Hannah is asking, Adam, what excites you most about working with clients?
What excites me most is that they're so like hopeful and joyous. They come in, they've been thinking about this thing forever, and
right.
They didn't understand how to make it happen at all. And then we
that
sit
is
down.
So true, Adam.
It's just their eyes light up when we start designing it real time. They see it building, and I'm asking them for their inputs. What about this thickness? What about this little angle here? What do you think about that? And they really get into it. And at the end of the process, they're always so happy. And we get the prototype, and they're just jazzed. And they go and they show all their friends. And we built some really good relationships with our clients.
Yeah,
some
awesome.
of which have been around for 4 or 5 years. We've been working with. So
that's great. So let's talk about the actual initial prototyping and the materials you touched on. Maybe one thing you don't necessarily do in-house, like metal printing, but what are some advancements in the past maybe 5 years that you're like, wow, we can actually do this in this type of material? What are some of those newest trends?
Yeah, I mean, the state of the art of 3D printing is really gone kind of crazy in the last 5 years. When I started out, I bought some machines from 3 Fusion in North Carolina, good machines. But like since then, things have gotten pretty wild. And part of that's, like Stratus has had a patent on a hot chamber. And so a lot of high temperature plastics, you can't print them if it has a hot chamber. And so now you're starting to see this new evolution. Now that the old patents are expiring from the big boys, now these smaller firms are able to integrate these machines and processes that are really important. So like high temp FDM printing, FDM fused deposition modeling. It's your standard hot glue gun style printer, runs around and does a 2D, and then it drops, does a 2D, and it drops. Like the hot chamber specifically on that, and the way that it was configured. And it's been a while since I looked at this, but Stratus, as I understand it, had that patent. And now that it's expired a couple of years ago, you're starting to see other companies come out with way cheaper. Stratus's machines were $250,000. And now for $5-10 grand, you can get a 3D printer that's got a very hot chamber, so it can handle really advanced materials like peak plastic that you have to print at like super hot temperatures. And the chamber has to be hot because of the warpage. Each layer that gets printed, it has a lot of thermal shrink. And so as you print that thing, if you don't have a super hot chamber, it just starts to fold on itself and it gets all messed up. So
bottom line, you're getting closer to being able to have, basically products ready to sell that you can just package up and sell.
Yeah. And that's there. I mean, there's some, technologies like nylon printing with a powder bed. MJ multi-jet fusion is a system that uses that. And those are basically production parts for the most part. You can't, like, when it comes to a production part, durability and not cracking is a really important thing. And so it's hard to beat that with like traditional injection molding and other heat operations. 3D printing, if you think about it, it's fusing it and making it in little tiny dots or little tiny lines, and it introduces a lot of stress concentrations within the part. And so that makes it so that it cracks, instead of those polymer chains being long and flexing, they're tight and up against each other. And so it introduces little stress concentrations. So 3D printed parts, to me, for the most part, it's not something you get a market with.
Okay.
You can do it for like 50, get a trial run, but a lot of times I advocate against that because, if your first foot forward into the market is a product that breaks when someone uses it, you'll get a bad review, and then that kind of sinks your ship before you even started. So,
totally.
The 3D printing is usually used for prototyping. And that's really important because once you prototype, you can actually understand the product before you spend all that money on the injection mold or the tooling for the expensive mass production process. And that's really crucial because, the cost to do a 3D print might be $100. The cost to redo your mold might be $10,000. And
100%.
so
Right.
the 3D printing is a game changer when it comes to validating your design before you go to production.
So yeah, that was the point I was trying to make. I think there's still that bit of a chasm. You got to take that big leap at some point.
Mm-hmm.
What do you do to help your clients? Can they reduce that feeling of anxiety? Right? Have they tried to sell a few or got them in the hands of customers, confirmed market research? What are the things you do to say, yep, we're ready to go 100 grand, invest in tools and get a big batch order overseas?
Yeah, a lot of times that can be done with 3D printing. We also do a lot of silicone molding in-house. So we have pressure casters to do high quality silicone molds. And so we'll cast those with 2-part plastics.
Oh, hold on. Actually, mold is plastic?
Yeah, we'll actually mold. We'll 3D print the part, and then we'll cast a silicone mold on that part.
Okay.
And then we'll cast that, and then we'll remove the 3D print and then cast the cavity with a 2-part plastic that has more durability.
Whoa. So is that trade secret stuff, or is that well known in terms of processes?
I feel like, well, I mean, to some, it's probably well known. The marriage of silicone molding, 3D printing is really, it's a tight connection. And we've been able to do some wild stuff. Like we're making, like I won't name the companies, but we're making parts that move high speed, like bottles on a production line. And so the way that we're able to achieve that is we 3D printed the part, made a silicone mold, and then we actually have laser cut pieces of metal that we're actually able to drop into the mold and then cast over the top. And so now you have this multimodal part that's got a metal chunk and then some nice flexible fingers on it, and you can move those parts. And that's something you could never do with 3D printing. I mean, not never.
Someday, right? We were saying that about
you never know. Like but using silicone molding to do castings opens up a whole field of possibilities when it comes to prototyping. And so if somebody wants 50 of something solid, we'll do a silicone mold and cast those parts for them to prove their market. And then once they prove it, then we go to China with it.
Yeah.
Adam,
you can't you can't go to the US. It is just, it's slower and it's a lot more expensive than working with China, unfortunately.
I'll just jump in here and give you some background on why I think what you do is so valuable to clients. A few years back, I had a client who went to market with a child-sized kayak that they intended to sell on Amazon. And they do sell it on Amazon, and they've been really successful doing it. However, if they'd work with someone like you as a manufacturer, someone who kind of has a more comprehensive view of manufacturing, shipping, product, inventory management, all that kind of stuff, right? It turns out their product was 2 inches too long to ship to Amazon without doing an LTL load, right? Like a pallet size product.
Sure.
So, yeah, and it's that's cost them tens of thousands of dollars every year, I'm sure, in shipping costs. But
yeah,
that's something that you would have got.
That's something new to me. I haven't run into that problem yet. But yeah, prototyping and being able to get the measurements on that final product can dodge a lot of
purpose, right? Or another example is I have a client who came with this really cool soap dish container.
Mm-hmm.
Well, when they went to manufacture it, no one considered how you're going to package this so you can ship thousands of these cheaply from China, right? And so these products didn't stack.
Right.
So,
that is something that we think about a lot. So products that are stacking, getting the angles right, and this is where the CAD comes in. To do a pencil sketch, you're never going to figure out how things stack well. To do it in CAD, you can actually, replicate the part and slide it and see where that interference is. And if it's got too much height to it, you change the angle, make it a little more steep, and then you can stack them a little lower until you hit it perfect. And that's that like what I'm talking about. It's like a holistic approach. You're thinking about manufacturing, you're thinking about patentability, you're thinking about function, and you're thinking about aesthetics all simultaneously. Because if you make something that looks cool, but you can't manufacture it, you're dead in the water.
Sure.
You know, and so in material properties, so if it turns out you need to make this thing out of sheet metal, to waste your time designing it for injection molding, you're going to waste all that time. So it's kind of a chicken or the egg situation, like material, manufacturing method, function. It's kind of a soup, and you just kind of look at it and you're like, okay, this looks like, you know, the direction we should go right off the bat. You start cruising down it, and if it needs to change, you change course as you go. Like I said, that's basically phase one. When that person comes in with that napkin sketch, we're thinking about the whole big picture right off the bat, so that when we print that prototype after that first meeting, we're already on the track for injection molding with ABS plastic. You know, we've already got the kind of path worked out. And once they take it and test it, if they find out, shoot, this doesn't work, it's too hot, we got to do it out of metal, then we can change course, but we at least have a starting block and we learn something. And that kind of goes to the patentability stuff. You know, it's, if you learn that this thing can't be made out of plastic because of this reason or that, now you've got something to go on. You don't have to talk about that in your patent. So when you're listing the types of materials this thing can be made out of, leave plastic out, or even talk against it. Because if the state of the art is all plastic and you know that doesn't work, you can kind of, you know, go towards and get your patent focusing on what actually works. So if your prototype has this little hook and that little thing, and we found out this little hook doesn't work, you don't really have to talk about it. But if you found out that that little thing does everything, focus on it and really dial your claim set in on that. And what I've seen is, you know, what seems like a pretty narrow claim is actually functionally very powerful. So a good example was when I was doing that CTO work, we were doing it was a plastic glove that had a coupon on it, and you tear the coupon off. It was for gas stations. When you are pumping gas, they do this in Europe, they don't do it in the US. That's probably why it didn't go anywhere, because no one wears gloves for pumping gas in the US. But
well, they have a lot of diesel in Europe, right? And that stuff stinks if it gets out.
Yeah, maybe that's it. But anyway, the patent basically consisted of, you got a glove, you got a redeemable member that is configured to be, you know, removed. And so the patent came down to placing that proximate to the thumb. And so if you think about that, if it's not proximate to the thumb, that's a crappier glove. So it's a very narrow claim that you've got this redeemable member that you tear off and it's right next to your thumb. That's how everyone wears the glove. That's where everyone is going to see the advertisement. So even though it's a pretty narrow claim, your competitor that put it on the pinky side, they're not going to make the sell relative to you. So that's where, like, doing all this prototyping and really functionally testing it and learning what is important can really improve your chances of success for patents down the road.
That's fantastic. Well, let's talk about that kind of early stage, you know, where it's kind of, it can seem kind of chicken or the egg, you know. Do you patent? Do you apply for the patent first, or do you go through another round of iteration and hang on? How do you balance that, and when do you bring a patent attorney in?
Yeah, and I've talked to a very smart patent attorney, and I see the same way he does. Like, if they have something to disclose, file a provisional and just get your line in the sand for what you have, knowing full well you're going to take it to rounds of prototyping and design and further improve it or whatever. But just to get your line in the sand allows you to talk about it freely with people. Because if you have a provisional patent, you're protected. If you have NDAs with people, yeah, you're protected, but it's not as, I don't think it's as robust as having a provisional filed. But, you know, we work with a lot of people that, you know, don't necessarily have the money, that they want to file a bunch of things, or they don't know the know-how, you know, they don't know the process. Yes. And so we do NDAs right up front with people that are doing patentable inventions, and then we work it, and then they wait until, and I'm just very, you know, don't tell anybody, don't put it on the internet.
Yeah, good. I think that's, I mean, I'm of the same thinking of whoever that smart patent attorney is. I tend to agree with them wholly. You know, you've got to be able to have enough, like you said, disclosure, enough to enable the invention, describe it so you can make it, but you want to have it be done pretty broadly so that you can kind of keep it generic because you really don't know the best way. You haven't really thought through manufacturability, like you said, or shape or design or material type, and you wouldn't want to pigeonhole yourself into one of those. So that's good. I like that approach. And I agree too that, you know, relying on contracts and NDAs, that can be fraught, you know, and you're also just taking the risk that someone else independently invents it and files it. And they're the first to file, even though you might have been first to invent. So waiting around trying to get it perfect, it's never going to be perfect, you know, so kind of walking the line there.
Yeah, and that brings up a good point. You know, once you file for that provisional, you have 1 year to do your non-provisional to claim that priority date, right?
Yes.
So the question is, well, what can we do in a year?
Right.
And so that's the really cool thing about kind of the state of the art right now with design and prototyping. I can go, you know, if I'm really hammering on something, I can do 8 iterations in a week or 2, depending on the object. And so it doesn't eat up all that year, you know, to like take it in and do some prototypes. You know, in one meeting we can discover a lot, even if that's all you do to increase your the quality of your disclosure.
Yeah.
It doesn't take much time these days to design something up and do some quick prototypes to figure out what works.
Yes.
You know? Yeah. And
when you mentioned your favorite types of clients, you know, the plumber with the new type of attachments, like they're going to go take that and test it, right? They're going to go see if it works. I mean,
it's great because plumbers have a ton of money. Everybody knows this, right? And I doubt, you know, my plumber friends, they're not on Fusion 360. You know, they're not, you know, drawing up CAD images, right?
Yeah, and that's totally true. You know, the plumber's going to plumb, and the 3D printer's going to 3D print. You know, it takes.
We're going to lawyer.
Yeah, and then you need a lawyer, and then you need your trademark. You know, you need your patent, and then you need your trademark. Yeah, it's a whole ecosystem of people doing stuff, and we kind of enable each other. And at the end of the day, we have cool products that we can make our lives a bit more convenient with.
Well, I want to give a moment to show off your brand. And by the way, I love your branding with this. It's really cool, simple star logo.
That's my business partner, Kyan, put a lot of TLC into the logo.
Well, I think it's pretty cool. Now you got the TM there. I got to defer to Matt. Is that the proper approach?
Yeah. If it's not registered, then the TM symbol is the way to go.
Okay. Yeah. And Adam, if you need someone to help you register, I do know somebody who can help with that.
Well, I do my own trademarks, but thank you.
Yeah, all good. Well, I want to just thank you, and for anyone that wants to follow up with you personally, get a project started. Denver 3D Print Co. Is where to go. And is there an email address I could give out publicly?
Yeah, it's lab@denver3dprintco.com, and it's all over our. And we have a form on our website. You can find. We got a phone number on there. We'll pick up.
All right. Yeah, that is that Denver 3D Print Co. Hopefully, I got that typed out right. Check out his website. So reach out on that email. I got it right. Okay, good. Why don't you hang out with us? We're gonna go do a critique of a Shark Tank pitch. I tried to find one that's 3D print related, but I might have actually messed it up.
You're fine, man.
Yeah. So if you don't mind, Matt and Adam, go on mute. I'll share my audio, and we'll get this going. All right. And Matt, give me a thumbs up on the audio once we get going here.
My name is Vlad, and I live in Brooklyn, New York. Originally, I'm from Kyiv, Ukraine. I was a curious little child. I would always run around taking things apart, sometimes not put them back together. The world was my playground. Unfortunately, my dad passed away and we literally lost everything. My grandparents immigrated to New York and my mom and I followed soon after.
How was your business?
We're good. I don't have an office for my business. I live in a one-bedroom apartment with my grandparents and my mom and my cat. So a lot of times I just go to a local cafe and I work from there. Kids are gonna love this. Creativity was a really big part of my childhood. I really wanted to have a product that puts learning into playtime. As you and Dad in Paris together. The hardest part about coming to New York was seeing my mom adapt all by herself with my dad not being around. I felt like I needed to be the man in the family and support my mom and make her happy. And that's why I worked so hard to make this business a success. What's up, Sharks? My name is Vlad, and I'm from Brooklyn, New York. I'm the founder and the creator of Print Block Building Blocks, and I'm here seeking $100,000 in exchange for 20% of my company. Sharks, the future of our children is in big trouble. Millions of parents are making one big mistake. They value school more than playtime. You see, in school, your children are bound by rules. They memorize and recite all day long. But playtime at home is when the self-exploration and the self-development actually takes place. It is then your little sharks develop creativity, decision-making skills, all the things that are really important for their success. Every day, more and more parents realize this and give their children the ultimate creative toy, building blocks. And that's why I created Print Block, which requires no manual, and every single piece is exactly the same. The long round pins on top of each block allow your models to bend and even fold. Kevin, I said every single piece is exactly the same, so it allowed me to take your beautiful face, pixelate it, and make a real-life mural.
Extremely attractive.
So Sharks, I need your help to unlock the creativity of our children and watch them build the future one print block at a time. Now, guys, I got some personalized gifts. How about I give them out? Robert, you're the protector of the cyberspace. You'll be our warrior for today. Here's your
I love it.
helmet,
Thank you.
and your dagger. Don't forget. Glory, you know QVC, but you forgot your crown.
So what happened
So,
with Toys R Us?
With the big box retailers, they're generally not there to seek out new products. I saw them just running from meeting to meeting, and they loved it. Like, yeah, this is really cool. Send us a sample, right?
So you didn't get any orders there.
No, I took some orders from smaller retailers.
Vlad, I'm
but,
dying to know your background. Where do you come from?
Originally, I'm from Ukraine. No, we didn't raise any money. I started with my best friend at the time, and we together pulled our money and we financed the prototyping, the production.
What happened to the friend?
My partner was in the back end, and I feel like he didn't feel connected to the business.
So does he still own part of it?
He still owns 15%.
15?
15. So I own the rest, 85.
And he's not there anymore.
No, he's not there.
But the other blocks, I can create stuff like this.
I disagree.
Not bendable.
Actually, I would ask, would you be able to make a crown? Would you be able to make a watch?
And do you have a patent on it?
Yes, I applied for 2 patents, and yesterday got my design patent granted.
So the design is of the shape of the piece.
The design is exactly how the piece
That.
looks like.
That's
Yes,
useful. I have to admit, this is interesting because it does a few things. The bendability plus the pixelation artwork is kind of different. You know, years ago, I sold my company to Mattel, and I worked there for a year and a half, and I got a pretty good dose of the understanding of the toy industry.
I own 85. So you, by taking 50%, you're becoming the sole driver of the company.
I want 50% of it. How you split up your 50%, Vlad, is entirely up to you.
Vlad, do you think you can do it alone? This is what it comes down to. Do you feel like you need that help?
Kevin, let's do a deal.
Nice.
Wow.
That's a few years back, but
JD, is that pretty common where one of the sharks will take a controlling stake in the company?
I haven't
I don't
seen
think I've
that.
seen that.
Yeah. I think Barbara kind of helped him kind of think through that on the spot. I mean, I didn't get a chance because I ran out of time doing all the research post filing. But I wanted to highlight that part about we're going for a design patent versus a utility. Kind of walk through the differences.
They sounded impressed with the design patent, but should they have been?
Well, design patents are not for protecting functionality, only for protecting the ornamental appearance. But they can have a functional effect, right? They can be functional, but what's the rights are just for protecting the way something looks. And so when they are vulnerable to designing around, because any substantial change to the shape or the look will not be infringing. And so that's one risk. I think here he kept that shape. And I think that is quite powerful. It's a great way to use a design patent. The 2 utility patents he had pending, they did not ever issue. At least I couldn't find any evidence of that. So it's a great way to affordably protect a specific shape. And what's cool about design patents is you don't need paragraph after paragraph of written description. It's really all about the drawings. So anyway, I want to highlight that point. At least was able to impress the panel of sharks.
Yeah, and I think to your point on design patents, so one thing that I feel that it does protect against is someone else using your mold. So if you have a design patent for your specific shape and you have a mold made in the Czech Republic and they're producing your parts, if they're going to produce parts for another country that you don't have a patent in, well, I take that back because whatever, it's all US. So they can't just make that part and send it to another company in the US and sell it, because your design patent is exactly the thing that you're having manufactured in that mold. So that's some small piece of protection you do get with design. Right.
Yeah. So, I mean, if someone came to you with, a product like this, I think I would say, make sure that that's, if you're going to go for only design, make sure that that's never going to change. Which is a tall ask. They're still in business. I checked them out. I mean, they're selling online. They appear to still be up and running. The actual trademark to me seems a little descriptive, Matt. Pin block, but it's not always not.
I went and looked at the USPTO or USPTO in the toy category for pin block or pin blocks. Didn't see anything. I don't know if I would call it descriptive, because when I was first introduced to the brand pin block, don't know what that is, right? Yeah. And it is somewhat suggestive of how the blocks work or what they look like, but it doesn't really speak to the building blocks themselves, in my estimation. So I would tell a client to go ahead and file that. One thing I did think was interesting is, well, a couple of things. One, they don't have a trademark application. So I wanted a bit of fun to actually see if that went through. But second thing is, what I noticed in the pitch was the inventor was talking about pin block and pin blocks. And I think that's kind of confusing, because I understood the brand to be pin blocks. And that's even what the Shark Tank header said.
Oh, the plural, non-plural.
The plural form, right? Okay. So that's something that I would talk to a client about and just have them really hone in on and pick a lane. Is it going to be pin block or pin blocks? And just stick to that to avoid, muddying the waters in the future.
Yeah, I see they actually are using that circle R. So maybe misusing that designation. You said you couldn't find a registered mark.
Not in the United States, at least.
Okay. Oh, God. Okay. Well, yeah.
What are the penalties using an R, a registered stamp, when you're not registered?
Nothing.
Nothing. Okay. Good to know.
Nothing. There's no trademark police. So,
right.
Yeah.
Something that comes across my I guess my advice to clients quite a bit is make sure to label, whether it be patent pending or a U.S. patent number. You're doing this quite a bit. Do you recommend that? What are some best practices for engraving or making sure that it's clearly identified the status of the product?
Well, you're always going to try to put it on the product if you can find some space for it. If it's a real small thing, like a little zipper pull or something like that, and you can't pull it off, put it on the packaging.
Right.
Always, that's a rule. You got to say that you're trying to get a patent, I run into that a lot, where it's people have patent pending and they'll keep it on there for years, and they shouldn't.
I don't know if this is zero for saying patent pending and not really being. I think there might be. Did we talk that before, Matt? There should be a good slap on the wrist.
There should be, because it really, that's one thing that we're doing a lot, is kind of looking at what the state of the art is, and then inventing around it. So if there's like actual, published applications or published patents with the USPTO or foreign, we can actually see what they're calling out, and we can work around and come up with other options. But if it's just a patent pending, it's a black box for me. And so if I'm helping someone invent a product around something and it's patent pending, I'm kind of like, well, I don't know what I can kind of guess what they're trying to do and then try to get around it by just looking at the object. But that's a real problem. But that kind of speaks to the power of patent pending. Like one of the, I think, kind of a hidden power of the patent pending is that it is a black box. So if you file a provisional application and you put a product in the market and you say patent pending, me as a designer, inventor guy, I have no idea what this person's trying to claim. And so I am, kind of remiss to try to work against it.
And you don't know, it'll take up to a year and a half sometimes before it'll actually get published. That's a huge period of time. Of course, they could decide not to file a non-provisional and just let the provisional go abandoned and it never gets published. Yeah, you're right. I think there is some power to that unknown. Not saying provisional pending. That'd be a big mistake. Don't do that. Don't say anything more than just those two words. Well, we got some thanks here from Gustavo to all three of us. So you're very welcome. Happy to share the information. And we've got a couple more minutes here. I think we'll probably wrap up here soon. So get any questions in if you have any.
I can speak to like to invent that thing that Ukrainian guy was working on.
Yeah.
If he came into our shop and he had a sketch and he had an idea, we would design that up. We would focus on the connection points and try to make that as funky as possible to kind of bring something new to the state of the art and teach somebody something to give you a shot at getting something like a utility patent.
Right.
And then when it comes to the prototyping, that's actually a tricky product to prototype because 3D printers need to be calibrated. And so your accuracy on a 3D print is going to be plus or minus a couple thousandths of an inch, on that small part. Now, if your fit is going to be needs to be so perfect for the thing to plug in and be removed in a way that feels good that, you might get a prints done on day one where they fit in perfect. And then that printer goes out of calibration a little bit after a week. Now the parts don't print so well.
Okay.
And so they don't fit like they used to. And so be hesitant to order, I'm going to order 10,000 of these things because half of them are going to fit and half of them are going to be, a quarter are going to be too loose and a quarter are going to be too tight. And so for that kind of product, we would 3D print, but we would do it in really small sections. One cool thing with the state of the art is there's some really good materials coming out. So there are some materials that have a little bit more flex in them. So you can kind of approximate an ABS PC plastic because the slide, not only how tight it is, but the surface properties of those parts are going to be really critical to how that slide works. And each 3D print is going to have a layer. Each layer gets printed like that. And so we would orient those parts at a 45-degree angle so that you don't have the hoops going on top of each other because that's going to make it grab a little bit more. And so the orientation of the print will give you a better prototype. But at the end of the day, I would suggest dial in on what you think works, get some prints, take some calipers to it to make sure your sizing is just right, and then get a cheap aluminum mold made that can kick out 100 of these things to dial in on the fit. And once you absolutely know that the material property, the material you're using, the fit is perfect, then you would go to mass production and do 50 cavities on the single mold that shoots them all at once of all the same color, and so that's kind of the progression. But that would be a tricky thing to prototype. And you're never going to your kind of goal with prototyping is to get the most production quality product you can. So the right material, the right flex, try to get all the properties as good as you can to be as close to production as you can be. But the thing is, with prototyping, you're never going to quite get there. There's always going to be this 5 or 10% difference when you go through a production manufacturing process. So injection molded parts are going to function different and feel different and look different than a 3D print. And so you can get it really far. And then with the mass production, you tweak and dial in. And so like for that part, you might make a mold and the parts don't quite fit right. Well, you can always take that mold, set it back on the CNC machine and buzz off just a little bit more material. Or if they're a little too loose, you can weld in some more metal and redo it. So molds can be adjusted after the fact. It's a little bit, there's some expense there, but it's not the same cost as like redoing the mold completely. So if you have a product, you get it really far, you can tweak the mold to some extent. And if you want it totally different, then you have to trash the mold and make a new one.
Yeah, I love that. I think it's what I hear, what excites me is you're providing these big building blocks of confidence jumps. Confidently, the client saying, "Oh my gosh, this is really possible." You can get them to the point where they can feel that curve, on their material, and get excited about the next step of moving forward and bringing it to market. So,
Absolutely.
Adam, thank you for your time. Really valuable insight. And Matt, as always, thanks for being with us. I think we're gonna wrap up. For those out there on Facebook, LinkedIn, YouTube, if you missed us, you're watching this after the fact, we're here every Wednesday at 1:30. Come join us, have some fun, ask a live question. All those podcast listeners out there, we love you. Hang in there. We're going to be publishing every week and breaking this out in different segments. So, Adam, Matt, have a good rest of your day. Go big, go bold.